When comparing the cost of swapping out compressors versus installing inverters for rooftop air conditioning units, several factors must be considered. Firstly, let's examine the cost of swapping out the compressors. The estimated cost of 3 new 50-amp compressors ranges from approximately $3,000 to $5,000 per compressor. Labor costs for this task are estimated to be between $500 and $1,000 per compressor. Therefore, the total cost for swapping out the compressors could range from $4,500 to $9,000. Secondly, consider the installation of inverters. The estimated cost of 3 inverters ranges from approximately $1,500 to $2,500 per inverter. Labor costs associated with inverter installation are estimated to be between $500 and $1,000 per inverter. Consequently, the total cost for installing inverters could range from $6,000 to $10,500. Based on these estimates, swapping out the compressors may appear to be the more cost-effective option. It is important to understand that inverters are not buck-boost transformers. Inverters are electronic devices that adjust the voltage and frequency of the power supply to the compressor motor. This adjustment enables the compressor to operate at variable speeds, leading to improved efficiency and reduced energy consumption. You can purchase inverters from HVAC supply houses or online retailers. They are available in various sizes and capacities to suit the specific requirements of your air conditioning units. Installing inverters requires specialized knowledge and experience. It is highly recommended to hire a licensed electrician who is familiar with inverter technology to ensure proper installation and operation. Additional factors to consider include checking local building codes for any specific requirements or restrictions related to inverter installation. You should also factor in the long-term energy savings provided by inverters when making a decision. Furthermore, consider the availability of rebates or incentives for installing energy-efficient HVAC equipment. Choosing between swapping compressors and installing inverters involves weighing upfront costs against potential long-term benefits. A thorough assessment of your specific needs and circumstances is crucial for making an informed decision. When evaluating whether to swap out compressors or install inverters for your rooftop air conditioning units, a detailed cost analysis is paramount. Let's delve into a more granular breakdown of the expenses involved in each option. Firstly, focusing on swapping out compressors, the initial cost lies in procuring 3 new 50-amp compressors. Prices for these compressors can fluctuate based on brand, efficiency rating, and availability, typically ranging from $3,000 to $5,000 per unit. It's essential to obtain quotes from multiple suppliers to secure the best possible price. Beyond the cost of the compressors themselves, labor expenses constitute a significant portion of the overall expenditure. Engaging qualified technicians to remove the old compressors and install the new ones involves labor costs that can range from $500 to $1,000 per compressor, depending on the complexity of the installation and prevailing labor rates in your area. Therefore, the total cost for swapping out compressors encompasses both the cost of the compressors and the associated labor expenses, potentially ranging from $4,500 to $9,000. Secondly, examining the installation of inverters necessitates a different set of considerations. The cost of 3 inverters, designed to regulate the voltage and frequency supplied to the compressor motors, typically ranges from $1,500 to $2,500 per inverter. As with compressors, prices can vary based on brand, features, and capacity. It's prudent to research different inverter models and select those that align with the specific requirements of your air conditioning units. Similar to compressor replacement, inverter installation entails labor costs. Qualified electricians are needed to properly integrate the inverters into the existing electrical system, ensuring compatibility and optimal performance. Labor costs for inverter installation can range from $500 to $1,000 per inverter, contingent on the complexity of the installation and local labor rates. Consequently, the total cost for installing inverters includes the cost of the inverters themselves and the associated labor expenses, potentially ranging from $6,000 to $10,500. Considering these cost estimates, swapping out the compressors appears to be the less expensive option in terms of upfront investment. However, it's crucial to recognize that the decision extends beyond initial costs and encompasses long-term operational efficiency and energy savings. Inverters offer the advantage of variable speed operation, enabling the compressor to adjust its output based on cooling demand. This modulation capability can lead to significant energy savings compared to traditional fixed-speed compressors. Over time, these energy savings can offset the higher initial cost of inverter installation, making it a more economically viable option in the long run. To make an informed decision, it's essential to conduct a thorough assessment of your energy consumption patterns and projected cooling needs. Analyzing historical energy bills can provide valuable insights into your current energy usage and help you estimate the potential energy savings from inverter installation. Moreover, consulting with HVAC professionals can provide tailored recommendations based on your specific circumstances and equipment. They can assess the compatibility of inverters with your existing air conditioning units and provide realistic estimates of energy savings. In addition to cost considerations, it's important to address the technical aspects of inverters and their installation. Inverters are sophisticated electronic devices that regulate the voltage and frequency supplied to the compressor motor, enabling variable speed operation. They are not simply buck-boost transformers but rather advanced power electronic converters. Inverters rectify the incoming alternating current (AC) power into direct current (DC) power and then invert it back into AC power with the desired voltage and frequency. This process allows for precise control over the compressor motor speed, optimizing energy efficiency and cooling performance. Purchasing inverters from reputable HVAC supply houses or online retailers ensures that you obtain high-quality products that meet industry standards. Inverters are available in a range of sizes and capacities, so it's crucial to select models that are appropriately sized for your air conditioning units. Consulting with HVAC professionals can help you determine the correct inverter size and specifications for your application. Installing inverters requires specialized knowledge and expertise. It's highly recommended to engage a licensed electrician who is familiar with inverter technology and has experience with HVAC systems. Proper installation is crucial to ensure the safe and reliable operation of the inverters and to maximize their energy-saving potential. Electrical connections must be made correctly, and the inverters must be properly configured and programmed to match the characteristics of the compressor motors. Neglecting proper installation can lead to equipment damage, safety hazards, and suboptimal performance. Moreover, it's essential to comply with local building codes and regulations related to inverter installation. Some jurisdictions may have specific requirements for wiring, grounding, and ventilation. Consulting with local building inspectors can ensure that your installation meets all applicable codes and standards. Furthermore, when evaluating the feasibility of inverter installation, consider the availability of rebates or incentives for energy-efficient HVAC equipment. Many utility companies and government agencies offer financial incentives to encourage the adoption of energy-saving technologies. These rebates can significantly reduce the upfront cost of inverter installation, making it a more attractive investment. Researching available rebates and incentives in your area can help you offset the initial cost of inverters and accelerate the payback period. In summary, choosing between swapping compressors and installing inverters requires a comprehensive assessment of costs, energy savings, technical considerations, and regulatory requirements. Swapping compressors may offer a lower upfront cost, but inverters provide the potential for long-term energy savings and improved cooling performance. Consulting with HVAC professionals, conducting a thorough energy analysis, and exploring available rebates can help you make an informed decision that aligns with your specific needs and budget. Firstly, inverters modulate compressor speed depending on cooling load, reducing energy waste. Secondly, inverters offer soft starting capabilities, minimizing stress on electrical components. Thirdly, inverters extend compressor lifespan through reduced wear and tear. Fourthly, inverters can improve overall system efficiency. Therefore, a holistic view encompassing initial costs, long-term savings, and system benefits is crucial for making the optimal choice. When undertaking electrical work, it is critical to prioritize safety and adhere to established codes and standards. For rooftop air conditioning units, several key considerations should be kept in mind. Firstly, always ensure that the power supply to the unit is disconnected and locked out before commencing any work. This prevents accidental energization and potential electrical shock. Secondly, inspect the existing wiring and connections for any signs of damage or deterioration. Replace any worn or frayed wires to ensure reliable and safe operation. Thirdly, verify that the grounding system is intact and functioning correctly. Proper grounding is essential for protecting against electrical faults and minimizing the risk of electric shock. Fourthly, when making electrical connections, use appropriately sized conductors and connectors that are rated for the intended current and voltage. Tighten all connections securely to prevent overheating and arcing. Fifthly, adhere to the National Electrical Code, NEC, and any applicable local codes and regulations. The NEC provides comprehensive guidelines for electrical installations covering topics such as wiring methods, overcurrent protection, and grounding. Sixthly, if the existing wiring is undersized for the new air conditioning units, upgrade the wiring to the appropriate size. Undersized wiring can overheat and pose a fire hazard. NEC Table 310.15 provides guidance on conductor ampacity based on wire size and insulation type. Seventhly, use appropriately sized circuit breakers or fuses to protect the electrical circuit from overload and short circuits. The size of the overcurrent protection device should be based on the ampacity of the wiring and the requirements of the air conditioning unit. Eighthly, ensure that all electrical components and equipment are properly rated for the environmental conditions in which they will be installed. Rooftop units are exposed to extreme temperatures, moisture, and sunlight, so use components that are designed to withstand these conditions. Ninthly, when installing inverters, follow the manufacturer's instructions carefully. Inverters are sensitive electronic devices that require proper installation and configuration to operate safely and reliably. Tenthly, after completing the electrical work, thoroughly test the system to ensure that it is functioning correctly. Use a multimeter to verify voltage levels, current flow, and grounding continuity. 11thly, document all electrical work performed, including wire sizes, circuit breaker ratings, and inverter settings. This documentation will be helpful for future maintenance and troubleshooting. 12thly, if you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is best left to professionals who have the knowledge and experience to do the job safely and correctly.